So the practice we're going to do here is going to confirm that not all problems are going to be straightforward. In an ideal world, in the case of the first problem, talking about a square, we might be given the side length of the square, and we would either be asked to solve for the perimeter or solve for the area of the square. And that would be very straightforward for us to do. And in the case of the second set of problems, in an ideal world, if we were talking about a circle as we are here, we might be given either the radius or the diameter and be asked to potentially solve for the circumference or the area. What makes these two sets of problems unique is that we already know the area, and we're going to have to work backwards to solve, in the case of the square, to solve for the length of the side, and in the circle, where we are given the area, we're going to need to work backwards to solve for the radius. But the problem doesn't stop there. Once we solve for the side length of the square, we're then going to need to use that information to bridge towards solving a different problem, specifically, what is the perimeter of the square? So we're going to work from the area backwards to find the side length to solve for the perimeter of the square. Likewise, once we work backwards from the area using the appropriate formula, we'll be able to solve for the radius of the circle, and then we're going to need to use that information to ultimately answer the question of what the circumference is. So these are really two problems where we are going to need to make use of two formulas, one to work backwards to find a missing piece of information, and then one to work forward to ultimately answer the question at hand. So in each of these problems, I'm going to walk you through the process. So let's get started. In the case of the first problem, I know that we're dealing with the square, as is pointed there. We're dealing with the area, and I know from our formula sheet that area equals side squared. Now I know what the area is. I know that the area is 25. That's given to me. So in this case, I'm going to replace what I know. 25 is equal to s squared. Now this is what we talked about. We're used to dealing with inverse operations. We're very comfortable knowing adding and subtracting our inverses. We're very comfortable knowing multiplying and dividing our inverses. What we have to get comfortable with is knowing that the inverse of raising something to the second power is the square root. So we're going to take the square root of both sides, and that's just saying, hey, find me a number in this case that multiplies by itself to give me 25. We should know by our facts that the square root of 25 is 5. That is the length of my side. Now, that is the key information that's needed to help me solve for the perimeter. So we could use a formula, or we could just use the basic fact that the perimeter is equal to all the sides added together. So we know the perimeter in this case would be 5 plus 5 plus 5 plus 5. All right, I'm actually going to convert that to green. So we're going to say 5 plus 5 plus 5 plus 5. If you wanted to be a little more creative, you could say that's 4 times 5. No matter how you look at it, the perimeter is going to turn out to be 20, and we just want to label accordingly. So we started with feet squared, but we know the perimeter is the distance around, so it's going to be 20 feet without the square units. Okay, so let me walk you through one more time. We knew the area provided to us. We used the area formula of a square. We worked backwards to find the side length. We used that side length and made use of it to answer the ultimate question of what the perimeter is. In this case, the perimeter is 20 feet. So the problem we're going to see down below with the circle is going to be very similar. We're going to work backwards because we're dealing with the circle. We know the area. So let's work with that formula. A equals pi r squared. Well, let's see. What's our area? Our area is 50.24. 24 We know pi is 3.14 times radius squared. Now here, you want to recognize that you're going to have to get this r squared all by itself. So we're going to have to divide by 3.14 on both sides. That's going to make the 3.14 cancel. It's going to give us r squared equals, that's going to give us r squared is equal to 16. Once again, we want to recognize that the inverse of squaring something, just like up above, was taking the square root. So we're going to take the square root of both sides. And you should be comfortable enough knowing your perfect squares. We know that 4 times 4 is 16. So the square root of 16 is 4. That is our radius. That is the missing information we need to now move forward with solving for our circumference. Don't forget, we have two formulas we can work with for circumference. We can either say C equals pi times D if we know the diameter, or C equals 2 times pi times r. And since I know the radius, that's the formula I'm going to make use of. So let's see. I'm going to say 2, oh, there's my 3.14 again, times 4. And we're simply going to calculate that. 3.14 times 2 times 4, which is the same as saying 3.14 times 8. Our circumference is going to be 25.12. And one more time, we want to label correctly. It's not going to be feet squared, it's simply going to be feet. So one more time, you're going to be given the area, you're going to substitute that into your area formula, you're going to work backwards until you get to your radius, and then you're going to be able to take that radius and make it the missing piece that we needed so that we could use the circumference formula, this one being 2 times pi times r, and finish up by solving for the circumference. So you've got 2 problems to work off of, to model after, to answer the remaining 3 problems for the squares, and the remaining 3 problems for the circles. So please get those done. Thanks.